in the previous module, I talked about the solution of theta equations, and from the solution of theta equations, what we did was up to recursion formula, we derived the recursion formula for the power series g theta, and I stopped there. So today we will, now in this module we will use that recursion formula. If you remember, the recursion the recursion formula is a n plus 2 n plus m plus 1 and n plus 2 n plus 1 minus beta an. Okay, so what we do, what we say, that in order to obtain a satisfactory wave function, it is necessary that g theta should be polynomial breaking up after a finite number of terms, and the series will break after nth term if the numerator of equation 9 is equal to 0. So numerator of equation 9 was n plus m plus 1 minus beta. So numerator of n plus m plus 1 minus beta is equal to 0. So what you can write? You can write n plus m plus 1 is equal to beta. Since m is 0 or an integer and n is also 0 or an integer, from where you got n and m, you see. N is, you get from here, n plus 2. So n is 0, 1, 2. M we talked about earlier, m plus 1, okay, mx. From here we have started with m divided by 2. So m is also an integer. M and m both are integer. So what you can write is n plus m and n plus m will also be an integer. So since m is 0 or integer and n is also 0 integer, therefore n plus m may be replaced by another integer L, which is also 0 or integer. And we can write beta is equal to L into L plus 1. Beta is equal to L into L plus 1. And what is beta? Beta is 8 pi square I e divided by h square. Okay. Beta is 8. So where L is equal to m plus n 0, 1, 2, 3. Okay. If you rearrange this equation, from where I got the beta value, if you want to see, beta value we got from the initial equation. When we separated the variables, this was beta value. 8 pi square I, this was beta value, 8 pi square I divided by h square. Okay. So if you use this beta value, then beta is equal to L into L plus 1. Beta is equal to L into L plus 1, and this is equal to 8 pi square I e divided by h square. If you rearrange this one, what do you get? Energy equal to h square divided by 8 pi square I L into L plus 1. And if I replace, just for symbolism, if I replace and I write E j is equal to h square divided by 8 pi square I, j into j plus 1, then this equation is known to you, and this equation is this is used in rotational spectroscopy or microwave spectroscopy, and this gives you the rotational energy levels, h square divided by 8 pi square I j into j plus 1. Okay, I am not going the right I. Okay, h square divided by 8 pi square I j into j plus 1. So the only difference is L is replaced by j, and you say j is rotational quantum number. So here also L is what? L is m plus n, and this could be 0, this could be 1, 2, and 3. Okay. So the quantization, and this L is actually another quantum number, azimuthal quantum number. So from the solution of this phi equations, we got m magnetic quantum number, and from the solution, that m is different from this m. Okay. So, and from the solution of azimuthal quantum number, from the solution of theta equations, we got the azimuthal quantum number. So both quantum numbers, one quantum number you are getting from the solution of phi equation, another quantum number you are getting from the solution of theta equations. So if you put L is equal to 0 value, then the energy level will be h square divided by 8 pi square I. If you put L is equal to 1, then 1 plus 1 is 2, and then again multiplied by 1. So 2h square divided by 8 pi square I, and in between you don't have energy, and the energy level is quantized. So as obvious, we should get the quantized energy level. Okay. Now substituting the value of beta in equation number 5, we have started with equation number 5. So if you substitute this value of beta, beta is equal to L into L plus 1. So the equation number 5 becomes equal to this one. This is what is beta we determined. Okay. Now we say the solution of this equation number 5 is actually called the solution of the above equation contains the factor called associated Legendry polynomial PLMX. There we were having Hermite polynomial, and we have written a generating function for Hermite polynomial. If you remember, I have written minus 1 raised to the power m and something like this one. So here we have a generating function 1 minus x square m divided by 2 dm divided by dxm PLX, where PLX is Legendry polynomial of degree L. Okay, this PLX is Legendry polynomial of degree L. Okay, so again, how from where we get it, don't bother about it, but the solution must have this term. The only idea is that any solution of equation number 5 will have this particular term. So we will try to find out the different terms, but before that we go for the normalization of the function. Okay, and if you as previously, we will not do here the normalization. I will write just the equations that according to the orthogonal properties of associated Legendry polynomial, we have PKM and PLM. Okay, so these are two different functions, and it will become equal to 0. Okay, and if you have PKM PLMX dx, this, if k is not equal to L, if k is equal to L, then it becomes equal to this one. So this was what? If k is equal to L, then both the functions are same, and this is the normalization condition, that both the functions should be same if k is equal to L, and then this is the value which comes. So if you find out the normalization constant, the normalization constant comes out to be 2L plus 1 divided by 2 L minus m factorial L plus m factorial. Very simple. This is the normalization condition, and you put this value PLMX and PLMX dx. This is already known to you, this integral. So this integral value you put here 2 into 2L plus 1, and then you get the n value. Okay. So normalization constant is root under 2L plus 1 divided by 2 L minus m L plus m. Both L and m are integer, I said you. Okay. So the total function total theta solution of the theta equations should be a normalization constant. There is normalization constant and an associated Legendry polynomial. Okay. So the complete normalized solution is this one. Now what is this PLM cos theta and how to find out its values? Okay. So this is very important, because this is going to generate many different functions which you will be using in physical interpretation of the theta equations. Okay. So we will do some practice of generating this PLM cos theta, associated Legendry polynomial, and the generating function is, I have written earlier also, 1 minus x square m divided by 2 dm divided by dx to the power m PLX. Okay, where the Legendry polynomial PLX is a Legendry polynomial, and this Legendry polynomial PLX is written as 1 by 2 raised to the power L factorial dl divided by dxl x square minus 1 raised to the power L. So for a few values of L and m, the associated Legendry functions in x can be worked out. The first task is to calculate. So whenever you want to find out any PLMX value, the first thing which you have to do is to find out the PLX. So the first thing is to calculate PLX and then put this PLX value here for a specific value of L and M, and then you get PLMX. So let's see how to proceed and how do we actually calculate. Okay. So see PLX and PLMX for few values of L and M. So if you want to find out P0x, then what you do? For P0x, L is equal to 0, so 2 raised to the power 0, L factorial 0, this is 0, this is 0, this is 0. So what do you get? Everything is 0, 2 raised to the power 0, 0 factorial, d0, everything I have written it. So this is equal to 1. For P1, you have 1, 2 raised to the power 1, 1 factorial, ddx of x square minus 1 into 1. Okay. And so P1x is equal to what? 1 by 2, and then you have differentiation ddx of x square, so this will be equal to 2x. And 2 and 2 will go, 2 and 2 will go, and you will have x. So we have calculated P1x and we have calculated P0x. So with respect to this, if you PLX we have, this is your, on the left hand side I have calculated PLX. Using this PLX we can calculate PLMX. So PLMX, if you put m also equal to 0, then it is P00x, and what is LMX? The for PLM, for PLM you have this equation 1 minus x square m divided by 2 dm divided by dxm PLX. So PLX is known to you. PLX you have already calculated. Now you write 1 minus x square, in place of m you write 0 divided by 2, then d0 divided by dx0 and p0x. So again it will be equal to 1. Okay. For 1 0, because 1 we have calculated, for 1 0 we have 1 minus x square, again m is equal to 0. Here also m is equal to 0, here also m is equal to 0. So again everything will be equal to 1, and you have x here. So PLX is equal to x. So this is the value of PLX, or I will write P1x. Okay. And rest of the thing is 0, is equal to 1. So it is equal to 1. But if you have P11, m is equal to 1, then you will have some functions. 1 means 1 minus x square 1 by 2 d1 by dx1 P1x, and this will be equal to P11x will be 1 minus x square raised to the power 1 by 2. So for any other combination of L and M, you can calculate P10, P20, P21, P and so on. Let's see. So P2x I have calculated again. So this is P2x calculation. For your convenience, just to make it you more acquainted with these calculations, rest of the calculations you will do on your own, but the simple initial calculations I have done. So P2x is known, P3x is known, P4x value I have calculated P1x, P0x, I calculated P0x, I calculated P1x, I calculated P2x, okay, and P3x, P4x I have given you the value. You try to do it, and this is your homework. This is your homework, and see whether you get this value or not. You will get it, because these calculations are very simple differentiations you have to do. Okay. Having done this, we can find out P20, because P20 is P2x and P2x value is known to you. So if you differentiate it, what you get P20 is equal to this one. So P20 is this one. Again P21, P21, P21 is actually this one. Okay. So these calculations you can try yourself, and you can feel comfortable that it's very simple calculations. And you don't need to mug it up. There is nothing which you should mug it up. The only basic equation is this one. PLMX is equal to 1 minus x square m by 2 dm divided by dxm PLX, where L and M are integers 0, 1, 2, 3, nothing else. Okay. So if you use 0, 1 value, first thing which you do is you calculate all PLX. So you calculate P0x, you calculate P1x, you calculate P2x, you calculate P3x, you calculate P4x, you calculate P5x, all these calculations you do. And thereafter, for a specific value of M, you can find out P00, P01, P02 and so on. Okay. So the first you will calculate PLX, and then you will put this PLX value into PLMX to get this one, and rest is the differentiating only, differentiating once, differentiating twice, differentiating thrice if m value is 0, 1, 1, 2 or 3. Okay. So you see here, we have differentiated once here, then we are differentiating twice here, one ds square by dx square. So ds square by dx square differentiation, if you differentiate it once, what it will be? It is twice of this one, x square minus 1 raised to the power 2, and so it's a minus b whole square, means a square minus 2ab plus b square. So you have x raised to the 4 minus 2x square plus 1. Okay. So if you differentiate this one, what do you get? The first differential will give you 4x cube and then 4x. This will be equal to 0. And the second differential will give you 12x square minus 4. Okay. And you have 1 by 8 outside. So because 2 raised to the power 2 factorial, so 1 by 8 outside. And this you can write as 1 by 2. If you multiply it by it's 2, it's 12, it's 4. So what you can write is 1 by 2, 3x square minus 1. Okay. So simply this term will increase. It could be d3 by dx cube. If you go for third value, it will be d4 by d5. So that number of times you will have to differentiate in order to get PLX. Okay. And once you have this PLX, then you can use this to get the PLMX. P20, P20, we have, this was P20, then P21. Again you see P21, only one differentiation you did. And P2x you already have. P2x is 1 by 2, 3x square minus 1. Just now I said you. So this you have to differentiate once, that's all. So rest of the term will remain, say 1 minus x square 1 by 2. Okay. And then if you differentiate 1 by 2, this 1 by 2 I have brought here, and then ddx of 3x square minus 1, and ddx of 3x square minus 1 will be what? 6x. So it will be 6x, 1 minus 2, 1 minus x square 1 by 2, 6x, and this will be 2 will go with 3, 6, it will be 3, and you will have 3x 1 minus x square 1 by 2. So very easily you get P21. So this way you can make a table of all the PLMX value and PLX value. P22 again I have done the double differential. So double differential will be differential of what? Double differential 6x differential. So 6x will become 6 now, because P2x is this one and single differentiation is giving you 6x, and you differentiate it again, you will get 6, because you will get 6 only. Okay. So this, once you start doing it, up to second you have done the previous case, the third is very easy, the third you have done, so the fourth will be very easy, fourth you have done, so fifth will be very easy. So it's all in one line. You can start doing it, and this you can make a table like this one, where in the L and M value is the first and second column, and then I have written the PLX value and PLMX value. All this value I determine. It is there on the board. What I did not determine is, so you try to find out what are the values. You will get a table in the book. Okay. In any quantum chemistry book, you will get these tables, which will tell you the value of associated Legendry polynomial and Legendry polynomial of degree L. Okay. And this is part of, this is the part of the theta equations, solution of the theta equations, because I said you that solution of the theta equation contains this term PLM cos theta. Okay. Where x is equal to cos theta I have written. So PLM x also you will find at some place. PLM x also you will find out. Okay. So in terms of, so this you require to do, this calculation you will do, and again all these is your home assignments, homework, because this will make you more facile in doing quantum mechanical calculations. So do these calculations and find out the value of P3 naught, P31, P32, P33, P40, P41, P42 and so on. Okay, at least this much. But now once you have these values, theta equations, then you have the theta functions known. Okay, so you have PLMX now, and the only part is your normalization constant, which is 2l plus 1 divided by 2 l minus m and l plus m factorial. Okay, so if l is equal to 0 and m is equal to 0, we write theta 0 0, and so you will have p 0 0 cos theta. Okay, and what will be the value? P 0 0 cos theta means P 0 0 x we already found in this table. P 0 0 x is equal to 1. Okay, so this part is equal to 1. Only this normalization constant will be there, and this comes out to be 1 over 2. So root 2 by 2 you can write. Okay, 1 by root under 1 by 2, or you write root 2 by 2. Both you can write. Okay, so this if it is 1 0, then what do you need? You need P 1 0 cos theta, and P 1 0 cos theta is what? P 1 0 cos theta is, go to the table, P 1 0 is equal to x, means it's cos theta only. X is equal to, so it's cos theta only. Okay, so cos theta only. Rest of the thing is root 3 by 2. Okay, 2 into 1 plus 1, so 3 into 2, root under 3 by 2. So you multiply it by 2 and 2, it will be root 6 by 2. Okay, so root 6 by 2 is cos theta. So this is the final solution of theta equation when using this associated Legendry polynomial. So if this final solution, and if you go for theta 1 1, then theta 1 1 again, we have done it for theta 1 1 is 1 minus x square raised to the power 1 by 2, and x is equal to cos square theta, so 1 minus cos square theta 1 by 2, and for 1 1 you have this root 3 by 4. Okay, so what you can write? 1 minus cos square theta is sin square theta, and raised to the power 1 by 2 will be sin theta. So so theta 1 1 will be root 3 by 4 sin theta. So the first thing is, so in a stepwise you find the theta solution. For theta lm, what you need to do is, if you have to find out theta lm, then for the first thing which you have to find out is PLX. Then the second part is finding out PLMX. And once you have, this is the first thing which you will have to do. Then the second thing is you find out the PLMX, and then third part is this one, getting the theta lm value, final solution of the theta equation. Okay, so this way, again for theta 2 0, theta 2 0 is what? If you go put to the table, theta 2 0 means P 2 0 we have found is 1 by 2 3x square minus 1. Okay, so we will use this one, and from where we got? We got it from this one P2x. So first thing is finding out the PLX, then second thing is finding out the P20, and then going for the theta solution. So theta 2 0. Okay, and this theta 2 0 becomes equal to 2 into 2 plus 1 is 5 divided by 2, and the factorial 2 minus 0, 2 plus 0, so it's 1 by 2, and then you have 3 cos square theta minus 1, and this will be 5 divided by 8, 3 cos square theta minus 1. Same way for 2 1, for 2 1 you get this one, cos theta sin theta. So this is the final solution which you get. Okay, root under 5 divided by 12, 3 cos theta 1 minus cos square theta 1 by 2. P21 cos theta is actually this one. Okay, okay, this is 5, 3 cos theta. Let me check. P21 is 3 cos theta. Okay, so it is 3. This is your P21 cos theta. Okay, so from where you get 1 minus cos square theta is sin square theta, under root will be sin theta, so cos theta sin theta. Okay, and this you can write as 15 divided by 4. Okay, so 5 divided by 12 could be written as root under 15 divided by 4 cos theta sin theta. So this way we find the solution of theta equations eigenfunctions. Phi equation eigenfunction was easy, very easy, because it was very similar to particle in a one-dimensional box. Theta equation eigenfunction is a little difficult, but not very difficult. And the only thing, if you don't want to do all those mathematics for the solution part of this equation, then what you should remember is this slide. This slide is important because this gives you an idea about the value of associated Legendry polynomial and Legendry polynomial. Okay, so how to calculate the Legendry polynomial and how to calculate the associated Legendry polynomial. These two equations are very important because from this equation, if you remember, you can write the solution for Schrodinger wave along with the normalization constant also. So this equation I would say this equation and this equation is sufficient for finding out the theta function, the solution of the theta equation or theta function, you say. Okay, so we talked about these solutions, and rest of the solutions also is there, P22 to this one. So what this table tells you the solution of phi equation and the solution of theta equations, angular part of the wave functions, we say. Okay, because both are angle. We did not talk about radius in rigid rotor. We talked about only the angle theta and phi equations. So if you look at the phi equations, it was for m is equal to 0, 1 by root 2 pi. For m is equal to phi is equal to plus minus 1, it was this one, and rest is repetitions. Okay, so this is your azimuthal quantum number. So it's 0, 1, 2, and magnetic quantum number will be 0, 0 and plus minus 1, 0, plus minus 2, plus minus 1. Okay, and then theta value for different functions I have written. Up to this, I think 2, 1. This also we have done it. I did it. Okay. So once you have this chart, this table where you have all the phi and theta values, then if you combine these two functions, the total wave functions you get. Because I said you, when you have a wave function which is dependent on more than one variable, then you can split this wave function into two independent functions, each depending on only one variable. Okay, so and the total function is multiple of this one. So the product of phi part and the theta part gives you the total function, and this total function is called spherical harmonics, and it's actually angular part of the wave function. Angular part. Why I am saying angular part? Because if we go for the hydrogen atom, there will be radial part also. Okay, in case of rigid rotor, I have taken the r is equal to 1 length, but always we cannot take r is equal to 1. For hydrogen atom, r is equal to 1 I will not take. Okay, there you will have to you will have the radial part of the wave function also. So if you look at these functions, here you have exponential I phi, exponential minus I phi, exponential minus I phi, exponential I phi, 2 I phi, minus 2 I phi. So all these functions are imaginary functions which you will have to convert into real functions in order to physically interpret this. That we will do in the case of hydrogen atom when we will come. And the actual interpretation of these spherical harmonics I will be doing there. If you want to see what is the plot of these functions, then look at this plot. This is a graph, circular graph, where you can plot this the sin theta and cos theta. Look at this one. What is plotted here is cos theta. Okay, so cos theta is equal this is your point 1, this is your point 5, and this is your 1. So cos theta is equal to plus 1 when the angle is 0. When the angle is 0, cos theta is here. Cos theta is 0.866 when the angle is 30 degree. So it is 30 degrees this one. Okay, so it is 30 degrees here. Then you have 60 degree 1 by 2. So 60 degree is 0.5, 1 by 2. Okay. Then you have 90 degree, it is 0. So at 90 degree it is 0. Okay. Then you have minus 1 by 2. So minus 1 by 2 here. Then again you have the same function repeated, minus 1 by 2, minus root 3 by 2 is again minus 0.866. So it will be here, and again minus 1 here. You can have a similar plot on this side also, because the theta value, it is a cos theta plot, and theta value I said you is the angle between z axis and your r value. Okay, so this r could be on this side, this r could be on this side. So a similar plot you can get it here also, in this direction also. Okay, so this is how we get the angular dependence of the wave functions. And if you look at this classical concepts of this rigid rotor, then from the classical concepts I have given you in the very first slide that kinetic energy is equal to L square by 2I. And what is the Hamiltonian? Hamiltonian is kinetic energy plus potential energy. Okay, and potential energy here, since it's a free rotation, so potential energy is 0. So we said the Hamiltonian is equal to L square divided by 2I. And energy we have already found is H square divided by 8 pi square I L into L plus 1. So what does it mean? If you use this Hamiltonian on this spherical harmonics, so your Hamiltonian is L square divided by 2I. What you should get? You should get the function back along with the energy value. And energy which we have determined is H square divided by 8 pi square I L into L plus 1. Okay. So this energy we have determined. Now what I say that the energy eigenvalue is this one. This we have already determined. Usually for rigid rotor, the symbol J is used for rotational quantum number, and therefore Ej is equal to H square divided by 8 pi square I J into J plus 1, where J is equal to 0, 1, 2, 3 and I is equal to mu r square. Okay. This quantity when converted into wave number, this equals to H square divided by 8 pi square IC, and this H square divided by 8 pi square IC is written as rotational constant B, and we say the energy is equal to B J into J plus 1. So if you use J is equal to 0 value, you get the energy equal to 2. Okay. Then the 0 value, energy is equal to 0. Then 1 E1 2B, E2 6B, E3 12B, E4 20B and so on. So what you see, the separation is 2B, 4B, 6B, 8B and 10B. That's why you get a transition from this to this will give you a line of 2B, a transition from this to this will give you a line of 4B, a transition from this to this will give you a line of, it is 6B, it is 12B, so 6B. Whether all these transitions are possible or not, this is given by transition moment integral. We will talk about sometime this transition moment integral. But before that, if you look at this equation, that energy is equal to H square divided by 8 pi square I, and what we say is that if you use this L square operator, L square Lx is what? Lx square plus Ly square plus Lz square, L square operator and the theta function, what you get is H square divided by 4 pi square L into L plus 1. This is the eigenvalue. So this value H square, H cross S square L into L plus 1 is the eigenvalue of total square of the total angular momentum quantum number. If you remember, when we found the phi function and we operated Lz on the phi function, we got the value of mh cross, this equation. Lz on phi m gave you this eigenvalue mh cross. And when you operate with the square of the total angular momentum on the theta function, then what you get? You get h cross s square L into L plus 1. So the physical significance of these two functions, phi functions and theta function, is that phi functions, theta functions represents L square value, a square of the total angular momentum quantum number, as well as this also tells you the quantization of energy value. So both the quantization of energy and quantization of the square of the angular momentum is the physical significance of theta function, and the quantization of z component of the angular momentum is obtained from the phi functions. So the physically these are significant quantities. Okay. if you use these two equations, then what you can write, L square is equal to Lx square plus Ly square plus Lz square. So what you can write, L square minus Lz square, you can write this one, okay. And if you put these values, L square value is what? L square is L into L plus 1 H cross square, and if I write Lz square, it will be M square H cross square, okay. So if you use this equation and this equation, if you use these two equations, then what do you get? You get L into L plus 1 minus M square H cross square is equal to Lx square plus y. Now you see, on the right hand side you have two quantities which is the sum of the square of the two quantities, okay. On the right hand side you have two quantities which is the sum of the square of each quantity, and so this will always be a positive quantity. What does it mean? Your left hand side should also be always a positive quantity, and if this has to be a positive quantity, it means it will be positive only when L into L plus 1 minus M square is greater than or equal to 0, and it will be positive only when M is less than L, less than or equal to L. What does it mean? It means that the value of M is restricted to 0, plus minus 1, plus minus 2, plus minus 3 up to L only. And this you already know, that if you have an azimuthal quantum number 0, then your magnetic quantum number will be only 1, 0. If your L is equal to 0, then the magnetic quantum number will be 0 only. If you have L is equal to 1, then magnetic quantum number will be 0 and plus 1, plus minus 1, 3 values. If L is equal to 2, then you have M is equal to 0, plus minus 1 and plus minus 2. Okay, this you have done it, but why it is so, why it is restricted, you see here from here, okay, because this equation tells you that why the value of M is restricted by L. So the value of M is restricted by L, and the total number of values of M is 2L plus 1. This fact was known to you. Now we have done it through the quantum mechanics, okay. So this is all about the solution of rigid rotor and the significance of theta and phi functions. We will I stop here for this module, and we will meet you in the next module. Thank you.